projects. In this video, we are going to explain about cognitive agent system to retrieve relevant code components from a repository. Introduction. The project's goal is to make it easier to find certain code logic among a large library of computer programs. Rather than relying on search engines such as Google, this project provides a cognitive agent system that is educated on existing code components in the repository. The system creates a model using machine learning, and when a user enters a query, the system uses the trained model to retrieve only relevant code components that match the query. The project provides an efficient and effective technique for programmers to identify the required code logic fast and precisely by pre-processing, transforming code to vectors, and generating graphs. Objective. The project's objective is to develop a fast and accurate mechanism for programmers to search and get specific code logic from a code repository. The system may process user queries and obtain just the relevant code components that match the query by training a cognitive agent system on existing code components and developing a model. The project intends to solve the issue of noisy search results from search engines such as Google by giving developers with a dependable and effective tool for swiftly locating the required code logic from a wide reservoir of computer programs, eventually expediting the development process. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Code Repository. In this module, the system allows the user to upload a code repository directory that contains multiple programs, each implementing different logics. The code repository serves as the dataset for training the cognitive agent system. Each program is associated with the program name, which acts as the training label, and the code itself, which serves as the training data. Second module is Pre-processed Dataset. The pre-process module is responsible for scanning each program in the code repository and applying data pre-processing techniques. This step involves removing unnecessary stop words from comments and code, which helps reduce the training data size and removes irrelevant information. Third module is Convert Code to Vector. The code to vector module converts the pre-processed data into a vector representation. It creates a mapping between words present in the code programs and their occurrences in each program. This mapping is used to form a vector representation, which is essentially a matrix. The column names represent the unique words and the column values represent the count of occurrences of each word in the corresponding program. Fourth module is Input Query and Retrieve Model. In this module, the system allows the user to input a query which represents the logic they are searching for in the code repository. The query is pre-processed similarly to the training data, and a test vector is generated for the query. The trained model from the cognitive agent system is then applied to the last vector. The model compares the query vector with the vectors of the program in the code repository and predicts the relevance of each program to the given query. Programs that contain the logic matching the query will have positive predictions, while others will have negative or zero predictions. And the fifth module is Query Result Graph. The Query Result Graph module generates a graph that visually represents the total number of predicted components from the entire code repository based on the input query. The graph helps in understanding the distribution of relevant code components across different programs. It aids developers in analyzing the query results and selecting the most appropriate code logic based on their requirements. Execution. For the execution of the project, we need to open the code folder. This is the code folder. To implement this project, we downloaded some Java repositories which contain programs from different technologies such as Hadoop, Hibernate, Apache, etc. All these programs are available inside this train model. And the code object, code vector, search vector, term vector, test. These all folders are the Python file which we have used in the main code to execute the project. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. this is the graphical user interface. We have created this graphical user interface by using Tkinter in Python. By using this GUI, we will interact with the project. Click on upload code dataset and upload train repository. I am uploading train folder which contains more than 100 programs from different technologies. So here we can see that the dataset is loaded. Now click on preprocess dataset to read all programs and to clean all programs by removing stop words and special symbols. So here we can see that name of each program is being processed. So we will get all the names of each program. So all name of each program is being processed here. And so pre-processing task is completed. After pre-processing is completed, we will get the total number of programs in repository, that is 101. Now click on convert code to vector to convert all processed program to vector. So in the above screen, we can see program name and its word and the count. So this is the program name, its word and the count. Now we will enter a query in the text field and click on input query and retrieve component to get all programs which implement that query. Once we build model that we can search, then we can search any number of queries. So here I am entering a query called value of. Now click on input query and retrieve component. So here we can see that big data and amount are the two programs which contain the logic of value of. So now we'll just close this. Now click on query result graph. So here we can see that the x-axis represents the total components and predicted components, and the y-axis represents the value of these components. We will close the graph, and here we can see that amount.java predicted score is this much, and concurrence reference hash map test.java predicted score is this much. Quit application. And the final conclusion of the project is the project successfully tackles the shortcomings of standard search approaches for locating code logic. The cognitive agent system efficiently obtains appropriate code components from a code repository based on user queries by leveraging machine learning and training. The preparation code to vector and query modules work together to provide accurate and speedy code retrieval, decreasing the noise and complexity associated with traditional searches dramatically. The project's graph module visualizes the expected components, assisting developers in comprehending the distribution of key code logic. Overall, this revolutionary solution streamlines the process of locating essential code components, increasing programs' productivity and efficiency.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.